Okay, so this is the second video. Let's go build our GraphQL server. I will be using TypeScript and Node.js, and there's a bunch of GraphQL server implementations in so many languages. I will be using this one called GraphQL Yoga. It's for Node.js, and we can, I think, just get started by clicking on documentation on the quick start section, and we're just gonna copy the code from here. But the thing is, I'm gonna create a GraphQL server that uses this API behind the scenes, and I'm gonna expose these resources behind a GraphQL schema. So that's the idea now. And I will start with the users and posts. Yeah, so let's get started. I will create a project. Learning GraphQL. Let's open it with Visual Studio Code. Okay. So first thing, because I'm using Node.js, I'm gonna just use npm and say npm init-y will give me this, so I can install the packages I want. And if you go back to this thing, it will tell you that you need to install GraphQL Yoga and GraphQL. So let's copy that, run it. And now I'm gonna install some kind of development dependencies that will make things nicer, or in some cases will enable us to use TypeScript. So npm install -d, which means development dependencies. I'll say TypeScript compiler ts node. I'll also install node1. I'll install this package. It will give us some nice coloring in the UI, in the CLI. And I'll install the types for node and the types for the previous package, which is the CLI color. And because I'm using TypeScript, I need a TS config. I already wrote one. I'm gonna just copy paste it. There in the description, you can't find a link to the code for this. You can just go there and copy this ts.config file, and that's it. Yeah, it's pretty simple. And for our scripts, I will just have one script for now called div, which will use nodemon. If you don't know nodemon, it's like a package will keep watching the file every time that file changes, or any of the files that this file references, it will read on it again. And it also works with TypeScript, so it's really cool. So yeah, I need now to create a folder called source. Inside the source folder, I will have a schema folder and index.TypeScript in both places, like in the source folder and here. Okay, I'm gonna increase the font size. So let's go back to GraphQL Yoga. We installed this. Now it tells us to define this thing called schema. Let's go to our schema file inside the index of TypeScript. And here's something really interesting about VS Code. Not sure if this will be the same in other editors or IDEs, but in VS Code, this is the schema, basically is it's just a string. So if I remove this, I won't get any syntax highlighting. I can also do this. This will give you syntax highlighting, and things like curly brackets, the auto completion from it will actually happen. You can do things like this also, these kind of movements. So it gives you much more freedom. There is another alternative. If your IDE does not support this, maybe it will support, if I go install GraphQL tag. I'm pretty sure you have seen this, maybe from Apollo, if you used it. People do this. This is called, it's actually strings mdn JavaScript. Okay, it's this thing. It's pretty interesting, actually. Yes, it's this. It's called tagged templates. So you see this function. This is how you invoke it. So I'm not sure what's the use case, but some people use it, and this package uses this syntax also. So this is a function that will take this as an argument and then do some things to it. But I prefer the comment. I think it's way simpler, so I'm gonna just do it. So it gives you some kind of syntax highlighting. That's the idea. And now, if you go back to Yoga documentation, it tells you to create the server. So let's go create it. And I installed this CLI package tool, CLI coloring thing. I can just do this. And I can say CLC blue bright. And I will maybe add a rocket. Now if I say npm run dev, so it's pretty cool. Now the thing that I showed you in the first video, this UI, it's already integrated with Yoga, which is really cool. It's called GraphQL. And this will read our current schema. So if we go back here, we have this type query, which in the previous video I showed you that this will be the starting point of each GraphQL query, and these are the root fields you can query from the, basically from here, from the root. So if I say query, you don't need to name it actually, you can do this, but let's say another one. If I just type control space, it should show me all of the things I can use. But if I also go here and click on query, I can see hello. Now, hit run, you can see hello. This will return to me what this function returns. So I think maybe this will give you a quick understanding of what this is. You have this type query, you have this field, and in the resolvers, this is called the resolver map. You will define the same types and then add resolvers for each field if you want. So another thing we can do, if let's say we can also return other scalar types. This is called integer. I can say number. And I think if I run this, nothing will happen. And oops, you can say number, but it will be null because there are no resolver for it. So we need to define a resolver here inside the query object. Say map.random. Probably because this is a float and it's expecting a number. So let's return maybe 1. So yeah, that's the hello world example in GraphQL. Now let's go and try to add an object type. So let's say type user. Let's say ID is a number. Name is string. And I highly encourage that you play around with these things. But let's go now here and say, first we need to define it in the query. So user will return a type user. Now if I go query this, you can either hit refresh, unknown type number. Sorry. So you don't need to every time to hit refresh to get the new schema. You can just say, yeah, this one. You can just click this. So now I get the user, but if I run it, I get nothing because it's null. Even if you add anything like inside of it also. Because we don't have a resolver for it. So let's define a resolver called user. This will return an object. I will have an ID 1 and a name. I'll put my name. So if I run this, now I get these values. So let's say you want to create a resolver for this nested field. The way you will do it, so these are the root resolvers. You need to define a key in the resolver map with the same name. So this will be user. And here, all of the So any function here that matches one of the fields in the user type will be invoked to resolve that field. So what I can say, so name will return, I will put a random emoji like this. So if I go now run it, this function will be override. This function will be run and it will override the values. So the returned value from here. But let's say you want to map the value that already you got from the root resolver. We have every resolver have 4 arguments. The ones that we care about now, one is called parent. This is the parent. This is the object that got resolved before this one, before this resolver got invoked. And remember we talked about the resolver chain. So this user resolver is the root resolver, will be called. Now GraphQL will see, hey, we have a resolver for the name field. This I'm gonna call it. But the returned value from this resolver will be passed here as the first argument, and we call it parent. So this is the returned value. This is the user. And the second argument is the arguments that you can pass here, which we will discuss later. So what we can do here, say parent.name. And now if I run it, I get the same name that we got from here, but I can also map it. So plus save, run again, boom. So yeah, I think this is pretty nice. So let's go and actually do what we wanted to do. So we have this API, and we need to create a GraphQL server that interacts with it and expose everything from here as a schema, or as a GraphQL API, sorry. So let's go to the user's endpoint, and let's create a type for this. Maybe I will filter this by 1. So this is the user type. So let's start doing it. We have a user, which we still gonna need, and I'm gonna add a username, which I can put them side by side actually. Oops, that's the old code. So I'm gonna have a username, an email, which is also a string. I'm gonna have an address, which will be of type address, but I need to create this type. So let's go here and create it. This will have a street, string, and also a string, city, string. I think you got the idea, so I'm gonna just make things a bit faster by copying the simple things. So we have a zip code. This is also a string. And then you have another, after the zip code, they have this property, which is also will be another object. So let's call it geo like this. So type geo. This will have these 2 properties, which are both string. One second, I'm gonna exit Telegram. Okay. Now we have the address. Now let's continue with the user. We have the phone, which is also a string. And we have the website, which is also a string. So I'm gonna just put them here fast. We have now the company, which is another object. So we need to create a type called company. And it's pretty simple. It's these 3 fields, and they are all just simple strings. So I'm gonna put them here. And I think that's it. Yes, that's it for the user. Our API runs. So if we go back here and run it, it's the same thing. But now we need to actually accept an ID, go to this API, fetch that user by that ID, then return it to the client. I'm gonna install Axios. Oops. npm install Axios. Oops. Oh, I wrote, okay, never mind. So import Axios from Axios. So these resolvers can also return promises, so you can define them as async functions. So the idea that we will call this API and put an ID here. This ID should be passed from the GraphQL interface or the API, from the client basically. Sorry. So the first argument for every resolver is the parent resolver. For this one would be nothing because we don't have a parent resolver. This is the root resolver. So I'm just gonna, it's a common practice to add underscore for these things. Now the second argument, this will be the arguments passed from the client. So these look like this. And you define them you can define them anywhere, but because this is a root resolver and this resolver maps to this field, I'm gonna define it here. And this looks like this. So ID of type integer. Now this field will only be, you will only be able to query it if you pass an ID. So now if I go here and hit refresh, so it's refreshing the schema. Oh, I'm not running the server. Okay, if I refresh the schema, come on. It should complain. Oh, maybe I need to add this. Okay, yeah, I need to mark it as required. My bad. So this is how you pass it. ID, I can give it 2. I return. Oh, we still don't get anything. But now if I go here and look this, you see ID 2. So I can just immediately destructure that. I can give it a type, ID number, and we get it here. So what I can do is convert this to a template string, inject the ID here, await that, destruct the data property, and return data. Hit run, we get the user. We can also query new things now because we added them. Username, can get the address, which is also another object because we defined it as another type. And also you can go, always you can come here, click to the user, and you can see the type of the address. You can see these things, and also you can, I mean, you can also get this UI thing indicator that, hey, you're doing something wrong. Always click or press command space or control space. You can see other things you can query. Geo, this is another object. Let's get the company, everything. So this is nice. Like if you compare this response with this one, like you only get what you asked for, which is something really nice. So you don't get this thing with overfetching. I only get the things that I want, and that's it. So that's pretty cool, and I think that's a really good example to start writing GraphQL with. Now, I'm gonna show you something with the resolver chain. So we talked about in the previous video, I also showed you an example where when the resolver call another resolver, this is called a resolver chain, and each resolver would pass down the value that it resolved to the next resolver. I also showed you example with the way we map the name for each user. So let's create a property called next user in the user type. The idea here that we get the ID of the user that got resolved, then we increase it by 1, we get the next user. So it's like a linked list of users. And this will also return a type user. Now if I save this, update the schema, I can here get the next user, and I can specify what I want from them. But I won't get anything because we don't have a resolver for it. And remember I said these are the root resolvers that are defined for the fields here. But if you want to create a custom resolver for anything defined in each type specifically, you have to put it in an object with the same key as the type name. So this is a resolver for the name field. Now we need a resolver for the next user field. This is a function. This is the parent, which we know is user. Maybe it's a good idea to define, let's go define types. There are some solutions where they can extract the types from GraphQL and convert them into TypeScript interfaces, but maybe that's another video, a video for another type, not a video for another time. So let's say export type user. And we can actually just, it's a bit funny, we can just copy this. But this will be number. Let's say any for now. Any equal. And let's copy the address. Let's copy all of this. And we can use the company here and add this here. And we can come back. Let's type these two things. And this also destruct what we need. Why not? I think that looks nicer. From this one, we need also the ID, only the ID. And then what we are gonna do, say exactly like this. Let's convert this to a asynchronous function. And let's put ID +1. And that's it. And this now this will look really cool. So let's update. Hit next user. We get the user of ID 3 because we started with 2. And because this is the next user is a property that points to the user type, which also have a next user. So I can do this. So I get the next user. Let's get the next user for that next user. You can keep doing this until you reach the end of users, which I think 100. So that's pretty cool. Let's do something more interesting. I think that's interesting. Like in my opinion, this is really interesting, but let's do something more. Let's define, oops. So this JSON placeholder API, it got all of these things are interconnected. They reference each other. So the posts, they have this user ID thing, and you can filter them. So if I say question, like I guess if I say title equal this, it will be filtered. So it's really cool. And I also can get that by ID. It supports so many things. Actually, if you go to the GitHub page, it supports way too many things. It's really cool. One thing you can do also is get the posts for a specific user. So if I say user ID equal 1, so this appears, okay, it gives me that. Because sometimes Chrome will convert this to a lowercase and it won't work. But if it's, okay, it works now. So this is a way to get the posts for a specific user. So that's what we are gonna do. And the post, let's define that type. And I know you might be wondering, like, do we actually define all of the types in a single string in one file? There are some solutions where you can define, I mean, this is a string, you can read it from a file, right? But you can also define multiple files, then merge them. This is called schema stitching. This is also another video in the future. So this will have a user ID, it's an integer. An ID, also an integer. Title, string, and a body, that's also a string. And the user will have an array of posts, and the way you define it is you just wrap the type of brackets. So this is an array of posts. Now, because we added this thing here, and if I go now query, let's go fetch the schema again. Let's say, give me the posts and give me the title for each one of them. I won't get anything because the first resolver, the user does not retain any posts inside of it, and we don't have any resolvers for it. And I can prove that to you if I go here and retain a posts array with objects, let's say ID1, and what other things I title this. I'll just put an oops. Sorry, let's put an emoji. You see, because it founded that in the object returned and it matches one of the fields, so it returned it, but we need that to be a resolver, not like this. So we go to the user resolver, we go define a field with the same, we define a key with the same name. This will be a function. Let's make it a cyclic function. And this will do something like this. The ID, will be the URL. And this will be the ID. And we get the ID from the parent resolver, which is this one. This returns a user. We can actually do this. Promise, make it more easier to understand. So this returns a user. Maybe I will actually rename this to user also. And this will be a user. So I will extract the ID. And that should be it actually. Now if I run this, we get an array of posts. See? These are the posts for each user. And I think that's maybe it, but maybe one thing that I can show you, because every post has an ID of the user, we can also do something like this, which it does not make sense in this example, but you can. So I can also link them in the types, and I can go, because of course I need to create a resolver for this, because the object user does not exist in the response, so I need to create a resolver that fetches it. And this resolver needs to be inside a key with the same type name. So this will be like this. And I can copy this actually, exactly. So we have a lot of code that is basically just copy pasted. And this, we don't even need the arguments, because we know this won't be a user, because the posts resolved an array of posts, and so this will be basically a post. So let's create that type. Let's go here and export type. Oops. Post. So ID is a number. User ID is a number. Title string. And body is a string. And this is TypeScript. So this is actually select all of these. There is a shortcut, but I forgot. Okay. And we also have a user, which will contain a user. I mean, to be fair, I'm not sure if we should define this one here, because this will be populated at some point, not always. It does not always exist. Maybe I'll remove it for now. So let's go back there. So this will be a post. Let's extract the user ID and let's pass it here. So this user resolver under the post type will be called for each post. And let's call it now. Let's go to the posts. I can get the user. Let's get the name of that user that wrote this. I mean, we know it, but you can do it now. So it's pretty cool. And as you can notice, the resolver that we defined for that type, this name, will also be run here. So things are really, this gives the user, the client, a lot of like flexibility when they query your schema. And it will lead to a lot of things. So it will lead to a lot of interesting things. So I can also put here next user under the posts, and I can get the ID, the name. I get the next user again. I can say ID, name, and here I can get the posts. I will get ID, title, and get then the user. I will get the next user for that user and get the name. I think it's notice that it's really slow now, but you see, I can go really crazy with this queries. But just by defining this simple schema. And so this is it for this video, but I'm gonna show you something we will continue on in the next video. First of all, these things are duplicated, but also I think you notice this is really slow. This is not good for an API. I'm gonna say let counter equals 0. And for each function, for each resolver, I'm gonna just increase the counter and log it. I wanna see how many times we actually send a request to the API. And let's go. So we called the API 245 times. This is not good. And we need to fix this. And the way you fix it is by batching all of these requests. I'm gonna show you this in the next video.